So this is programming in Java. We are in the module 4, and in the module 4 we have packages and interfaces, and later we have what is known as the exceptions. So we have finished the packages part and we are in the interfaces part. We have considered the basic what we call basics of the interfaces. Now we are going for what is known as the nested interface. So nested interface just means that you can have a interface within a class or an interface. Okay, you can have a interface within a class or a interface. So that just means an interface can be declared as a member of a class or another interface. Such an interface is called a member interface or nested interface. Okay, so a nested interface can be declared either as public, private, or protected. However, the top level interface should always be declared as public or use the default access level, either public or default access level for the top level interface. But a nested interface can be either public, private, or protected depending upon how we want to access it. So when a nested interface is used outside of its enclosing scope, it must be qualified by the name of a class or interface of which it is a member. So say if you write a particular class, then within that you put the interface, and within the interface you might be trying to implement a what you call you might be trying to implement that interface. Then you need to write the class name dot the interface name. Okay, another class implements class name dot the interface name. However, we'll see the example. So thus outside of the class or interface in which a nested interface is declared, its name must be fully qualified. Its name must be fully qualified. Let us take an example of the same. So here we have a class A, and within which we have put a nested if interface which is declared as public. Within a class A, we have a nested if interface which is of the type which is public. So now B implements this interface. So we'll say class B implements A dot nested if, because this nested if is within the class A. We need to write here as A dot nested if, because this is not the top level interface. It is rather within the class A. It is acting as a member of the class A, and hence we need to write A dot nested if. Okay, implements A dot nested if. Public boolean is non-negative int x. So we have a function here is not negative, which is of the type return type will be boolean for this, and again it's having a modifier which is public. Int x, now it's having a parameter, a single parameter x of the integer type, and if the x is less than 0, it will return a false. That means if it's negative, it returns a false, and if it is greater than or equal to 0, then it returns a true. Okay, if it is greater than or equal to 0, it returns a true. So here we have a what you call demo program, nested if demo. Now this nested if interface here at the interface definition has a is non-negative method, which is just a declaration. Its implementation is not there. We know that in the interface we don't do the implementation, only the declaration. Okay, we just do the declaration. We don't write the body of the method, but the body of the method should be, again, that means we should try to what you call implement it within the class B, which what you call, so to say, implements the interface. Okay, so is non-negative has been implemented here, it's not implemented here. Now coming to the what you call demo, where we have written demo class, where we have written the main method public static void main. Now we are creating an object of the what you call class B. Okay, the class B, object of the class B by new B here. Okay, but we are just assigning it to the member of the nested if what is so to say a variable associated with the nested if interface or a dot nested if interface. Okay, so this is just a variable and this refers to a object. Okay, so if nif dot e is not negative, so this nif will go to the corresponding, because a dot nested if is there, it tries to find out, in the a dot nested if whether the it's implemented, it's not, whereas in class B it is implemented because we have here class B. So there it will, going to call it gets associated with this and calls it over here. Nif dot is not negative 10 will go to this, and 10 will be passed to this method, and this 10 is greater than or equal to 0, and it returns true, and hence system.out.println 10 is not negative will be printed. However, if we write, if nif dot is non-negative -12, okay, this is -12, so -12 is passed over here. This is a less than 0 value, so it returns a false. False comes out here. If this is false, then naturally this won't be displayed. Okay, this won't be displayed. However, if you want it to be displayed, might be you can try to write over here as not nif dot is non-negative -12, not nif is not negative -12, and then you can write -12 will be a negative value. -12 will be a negative value. It depends upon you what you want to implement. So class A defines a member interface called nested if, and that is declared public. Class B implements the nested interface by specifying implements a dot nested if. Inside the main method, a dot nested if reference. So this is reference called nif is created, and it's assigned to what you call an object of the B. New B will correspond to an object, whereas just this is a reference of a dot nested. So because B implements nested if, a dot nested if, this is legal. So because this becomes positive, it goes to the statement. Because this becomes negative, or rather this becomes true, it goes to this. Because this becomes false, it does not go to this statement. Okay, it does not go to this statement. Now let us try to run this code by going to the JDoodle. Rather, let us take it from the book itself, the code for this, and try to copy it into the JDoodle and run it. So only class A is there here, so that we can type it as well. Let us take the code from here. Then we'll go to the JDoodle. Let us see whether in the JDoodle it will be able to run this program of interface or not. So I need to write here class A. Then a opening brace. Okay. Then we'll write this. Oh, no. This closing should not come. Okay. So the other thing is wherever the main method is there, that should be declared as public. So main is there here. So this should be declared as. So let us see whether we can run this. Illegal start of the type. This is a nested interface. Semicolon expected. Nested is demo.java. Okay. I think this should be a double backslash. Yes. So it's giving us 10 is non-negative. We can change this code. It might be you can try to write over here a not. Okay. So not false will become true. Now, in place of this is not displayed, we can write here, 12 is minus 12 is negative. Okay. Or the number is negative, whatever. Okay. Minus 12 is negative. Let this be there. So we will now execute this. So 10 is not negative, minus 12 is negative, right? Because we have put here not. So this is the way we can, run the code. Okay. So let us go to the, next topic. Applying interfaces. So multiple implementations of an interface through the interface reference variable can be done. For example, you have here an interface, my interface. Okay, this is a top level interface, which has a method, which is, method, so to say, declaration, which is of the return type void, print string message. Okay, so return type is void, and we have the declaration of the method, no definition. Then we have here class my class one implements my interface. We have a class here, my class one, which implements this interface. So whatever method is there within that interface should be, defined over here or implemented over here. So public void print string message. So signature of this should be same. Okay, only qualifier is mentioned here as public. System.out.println message.length. Then class my class 2 implements my interface, public void print string message, system.out.println message.length. Again here, plus the particular message, the other way around. So this and this, you can see we are just writing the other way around. First here the message and then the message length. Here the message length first and the message later. So this can be considered as polymorphism because we have the same method, but implementation within the my class 1 and my class 2 are different. So here we have a demo class, public class interface applied test, public static void main string dots, where we have the main method. We are creating two objects of the my class 1 and my class 2, MC1 and MC2, and the my interface mi we are trying to write, and mi we are assigning to each one of those objects MC1. So this is just a reference variable mi, whereas these are objects over here. So to the reference to the reference variable, we are assigning the object for MC1, that is my class 1's object, which is MC1, and then we are trying to call mi dot print hello. So this goes to the print method within the my class 1, because mi is the MC1 is the object of the my class 1. Similarly, here we have my mi is equal to MC2, that is the reference variable mi of the my interface is assigned with the object of the my class 2, which is MC2. So then it calls the my print, mi dot print will call the print method within the my class 2, because the MC what you call MC2 is within the MC2 is the object of the my class 2, right? So each case, in the first case, it will print the message and then write the length. In the second case, it will print the length and then the message. Okay, so this gives us what is known as the runtime polymorphism. Okay, so accessing multiple implementation of an interface through an interface reference variable is the most powerful way that Java achieves the runtime polymorphism. Okay, so let us try to again go to the book and take the code and try to run it and see the output, whether whatever we are expecting is same or not. Oh, totally a different program is there in the book. Okay, let us try to see whether we can take the code from here. No, we can't take it. So we need to type this program and run it. Okay, let us forget it for the time being. Now let us go for the what you call the example which is given in the book for the same, and then see what he's trying to do there. Okay. So here he is trying to implement the stack using the interfaces, right? So interface int stack is the name of the interface. We are trying to have two methods within that, push and pop. Again, only the what you call method declarations and no implementation of the method here. Then here we have the class fixed stack, which implements the int stack, and we are considering private int stack, private int toss as the two different variables. Okay, allocate and initialize the stack is what we are trying to do here. So that just means that we have the fixed stack and fixed stack method. That just means that it is the constructor fixed stack in size. So this is the constructor where we are trying to assign what you call stck is equal to new int size, okay, and then toss equal to -1. Then we are trying to call implement the push method, so to say, within this, because fixed stack implements int stack and push and pop are part of the int stack, and hence they have to be implemented over here. So public void push int item if toss is equal to stack length dot -1. So we'll try to push if only when the stack is not full. If the stack is full, then we should just indicate that stack is full, and we should not try to overflow the stack. Okay, we should try to just indicate and not put anything more onto the stack if it is full. Else stck plus plus toss is equal to item. So on the top of the stack, the item should be put if the stack is not full. If the stack is full, then you should indicate that it's full. If it is not full, which is given by this or here, then the item should be pushed onto the stack. So that's the what you call implementation of the push method. Then we have the pop method, public int pop if toss less than 0. Okay, then if it is less than 0, then we should say that the what you call stack is empty, or there is an underflow in the stack, and return a value 0. Else return top of the stack minus minus. So that just gives us that top of the stack is popped out, and then we should decrement the pointer so that it points to the new top of the stack. Okay, it should point to the new top of the stack. Similar to saying that here, we first increment and then we push onto the top of the stack the value of that top. Okay, we first increment the pointer and then push the item onto the top of the stack by this so to say array. Whereas here it's the reverse. That means you pop the item on the top of the stack first and then decrement the pointer so that it points to the new top of the stack. Now we have a test of the main class over here. Class if test public static void main string args. So fixed stack my stack 1 object we are trying to create here, my stack 1 and my stack 2. Then we have written here for I equal to 0, I less than 5, I plus plus, my stack 1 dot push I. That means we are trying to push 5 items onto the my stack 1, whereas in the next statement for int I equal to 0, I less than 8, I plus plus, we are trying to push here 8 items onto the object associated with the my stack 2, the stack associated with the my stack 2 object. Okay, then pop those numbers off the stack. We are trying to pop them off by writing the statement and then this statement, because here we have 5. Correspondingly, it is I equal to 0, I less than 5 plus plus. Because we have 8 here in the second stack associated with the object my stack 2, therefore we need to pop the 8 elements. Okay, so here it just gives the same implementation of the push and pop method for 2 different so to say what you call objects, right? So we will get the result accordingly, but the next program will show us a little difference. Okay, so here we are writing a dynamic stack class. Dynamic stack implements din stack implements int stack, private int stck array, private int top of the stack, allocate an initial stack. So that means we are having a constructor here, and now you can see that we have the push here. Now if the stack is full, allocate a larger stack. So because it's a dynamic stack, we need to increase the size of the stack. Okay, we need to increase the type of the stack if it is a dynamic stack. So if it is full, we increase the stack. Otherwise, if it is not full, we just push it on the item onto the value. So first increase the size of the stack over here and then push the value of the item over here. Okay, then in the pop it is again just the standard. If it's less than 0, then we should indicate that the stack is empty or underflow, and if there is something, we should pop that out and take it out. Okay, so dynamic and static just means in the static case we have a fixed size of the stack, and dynamic is just variable length. That means first if the stack is already full, we just double the size of the stack and then go for pushing the item onto the stack. Okay, so for all that we have written this statement: int temp array is equal to new int stack dot length, you know uh, multiplied by 2. So we are increasing, we are making a temporary array, again corresponding to the stack itself, whose length is double of stck, right? And corresponding to that, we are just trying to write here for int I equal to 0, I less than stack dot length I plus plus. We are just trying to write temp I is equal to uh, stcki. So whatever was there, we are just trying to copy it into the temp over here. Again, we are writing it back. Stck is equal to temp. We are just reversing it back over there. That is, whatever is there in the temp, we are writing it back into the stck, and then we are pushing the item. So now the size of stck has become double of the earlier value of stck. I think this gives a little different implementation compared to what we might have considered in the earlier example. So let us take this code over here. And then go to the JDoodle, copy it there, rather paste it there, and try to run the code. So again, wherever the main method is there, that should be declared as public in JDoodle, otherwise it will not accept. JDoodle is not going to accept that. Now let us try to run this code. So again, there is a error. So this is in class fixed stack implements in stack. Okay. So we don't have the in stack. We have not written that, and that is the mistake. So we should go back in the book and then take that code also. In addition to the code which we have here, yes. So we need this. This we have not copied. Okay. So we have copied it now, and then we can run. Okay. So we are just trying to put the values 4, 3, 2, 1, 0, 5 different values, then 8 different values in the second one. Okay, so size of the stack here is 5, the size of the stack here is 7, right? So 8 here, 5 here, 8, 4, 3, 2, 1, 0 is there, 7, 6, 5, 4, 3, 2, 1, 0. Okay, this is the what you call stack, which is static. Similarly, if we go for a dynamic stack, and then copy it there in place of the fixed stack. Let me see where we are. Start to, yes. So I need to take this and put it here. So can I run it, or is there an error? Okay, we are not declared public. So no public class. So we need to make this public. Okay. So you can see that the size of the stack, my stack 2 has, doubled. Here also it has doubled, right? So it has become now from 5 to 10. It has become now from, might be 20. The size here might have increased to 20. Okay. So size of this might have increased quite a lot. So then he has put here another one which uses both the fixed stack as well as the dynamic stack implementation. Okay, so that we can always check by copying this and running, but at that time again we should remove this what you call where the main method is there here. We should replace that by this should be the one which should be put in place of the uh, you know this should be the one which should be placed in place of the program which corresponds to within the JDoodle. We should try to write in place of this. But again, for this, we need to have the what you call the other one also, that is the static stack also. Okay, static stack also. So let us take that static stack also from the earlier page. Fixed stack also. So where is the implementation of the fixed stack that we can, this is fixed stack, yes. Fixed stack implementation should be copied. Okay. Yes, till this point, we should copy it there. Before the dynamic stack. Not only that, where there is main method, we should declare that class as public. Okay, so now we can run it. Okay, so we have here the values in the dynamic stack as well as the values in the fixed stack. Okay, values in the dynamic stack from 11 to 0, so 12 values. Here only 8 values in the fixed stack. Okay, so it depends upon how many values we are just trying to push and how many values you're trying to pop. So if there are any doubts, we can take it. Otherwise, we'll stop for today and continue in the next class.